All right, welcome to Math Made Easy Day 4. Today what we're going to be doing is we're going to review some problems like the kinds that you would see on your STAR test. So let's go ahead and get started. So, first one. The set designer for a play painted some background scenery on a large piece of plywood. He used a 13-foot long pole to hold a piece of plywood upright, as shown below. What is H? So on this one, they want to know the entire height, this entire thing here. So that includes two different components, the 2 as well as the guy that's missing. So I'll call this guy A, B, C. So what I'm going to go ahead and do now is I'm going to write out my formula. A squared plus B squared equals C squared. So I'm going to go ahead and color code them just to make this easier. C, B, A. Let's go ahead and plug them in. Okay. Now I can go ahead and use my calculator. And I'm going to type in 5 squared, 13 squared. Okay, so I'm going to go back over and write that down. A squared plus 25 equals 169. I'm going to take away the 25, and I get a squared equals 144. At this point, I know every single time I should take the square root to get rid of the square. I do it to both sides. So I'm going to say square root 144. And it says A is equal to 12. But something interesting to note about this is that means that this part is 12, right? So let's go ahead and color code that, this little turquoisey color. So that part is equal to 12, but H is equal to A plus 2. So H equals A plus 2, right? Because I have to add this guy and this guy together. So H is equal to 14. And I want you guys to go ahead and practice bubbling it in. Everywhere you see a blank space, we're going to go ahead and put in a 0. And there's my answer. All right, second one. So here they're asking us, what is the closest length of the ramp in feet? Okay, so I'm going to look at this. I see my 90 degrees opposite, that's C. So this is the guy I'm looking for. I'll call you A and B. A squared plus B squared equals C squared. All right, let's go ahead and color code these. So my A's, my B's, as well as my C's. Let's go ahead and plug them in now. Okay, so I'm going to go ahead and type into my calculator 3 squared plus 9 squared. I'm going to make it easy on myself. So 3 squared plus 9 squared, enter, is 90. So if I go back over here, I'll see that 90 is equal to C squared. In order to get rid of that squared, I have to take the square root on both sides. That gives me C is equal to the square root of 90. Let me go ahead and type that in. 9.48. 9.48, and the closest one to it is H. All right, number 3. So here they're asking us kind of a weird question. They're asking us which one of these is true. So whenever we multiply this number, so C's, A's, and B's, right, really this is going to be all B over here. These are all C and all A's. So if I took all of the squares that would make in here as well as here and added them together, they'd be the same number of squares as over here. So let's read through these answers and decide which one it is. A, the number of tiles needed to cover region X is the same as the number of tiles needed to cover both regions Y and Z. So if I add together Y and Z, it should give me X. That's not true. The number of tiles needed to cover region Y, that's this guy over here with the B, is the same as the number of tiles needed to cover both region X and region Z. So if I add together my C area and my A area, it should equal B. That's not true. Last one. This one should be right. The tiles needed to cover region Z is the same as the number of tiles needed to cover both region X and region Y. So that means that this guy is the same as adding these two together. That's true. So my answer is C. Number 4. So they told me a lot of crazy stuff, right? I don't even know what's going on here. But I do know my Pythagorean theorem. So I'm going to go ahead and draw in my 90-degree angle, C, A, B. Well, how am I going to get measurements? They gave me these coordinates. I don't know anything about that. Well, let's count the boxes. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now I have measurements for sides A and B. A squared plus B squared equals C squared. We don't know who our C is. We do know A is equal to 12. And we also know that B is equal to 5. Let's plug them in. 12 squared plus 5 squared equals C squared. Okay? 12 times 12, 144, plus 5 times 5, 25. Let's combine them. Okay, I don't know what the square root of 169 is, so I'm going to go ahead and just type it in. Okay, and it looks like my answer is 13. So I go back. How would I bubble this in? Well, first of all, I would say, let's go ahead and write it in. 13, everywhere that's blank is a 0, and this was a positive number. Let's go ahead and bubble in now. Okay, got that one. Next one. Which measurement could not represent the measurements of a right triangle? So remember, all we're doing is we're plugging all three of them in, okay? So I'm going to go through and make sure all of these have C for the last one. So biggest one's here, biggest one's here, biggest one's here, biggest one's here. Okay, so those are all my hypotenuses, right? So I'm going to say my formula, okay? And I'm going to write out each one of them over here, and then we're going to test them in the calculator. So now I'm going to go ahead and highlight my B's, as well as my A's. All right, let's plug in each one of these. 6 squared plus 8 squared equals 10 squared. 12 squared plus 35 squared equals 37 squared. And we're looking for not a right triangle. So we're looking for a 0 in the calculator. 4 squared plus 6 squared equals 10 squared. 10 squared plus 24 squared equals 26 squared. So let me go ahead and type all these into the calculator, and let's see which one is true. 6 squared plus 8 squared, second test, enter. 10 squared. So that's a 1. That means that is a right triangle. Okay, let's try the second one. 12 squared plus 35 squared, second test, enter. 37 squared, enter. That's also true. So that is a right triangle, not the one we're looking for. Next one, 4 squared plus 6 squared, second test, enter. 10 squared. That's false. So that is the one we're looking for. This is not a right triangle. But let's try the fourth one. 10 squared plus 24 squared. Second test, enter. 26 squared, enter. And that is 1. So over here, I found it is 1, it is 1, it is 1, it's not. My answer is C. Okay, next one. A 10-foot ladder is leaning against the wall. The bottom of the ladder is 4 feet away from the base, as shown below, which is the longest closest distance from the top of the ladder to the base of the wall. So they want to know this red line. So first I find my right angle. Opposite is my C. And then over here, I just call them A or B. I'm going to write out my equation. Okay, I'm going to go ahead and categorize these. So here's A. Here's B. And finally, here is C. Okay, let's write in those values. A, I don't know. B is 4. And C is 10. Okay, so A squared plus 4 times 4 is 16. 10 times 10 is 100. Now I'm going to go ahead and move the 16 over. And I end up with A squared is equal to 84. Now I'm going to go ahead and take the square root of both sides. And I'm just going to type that in to make my life easy. Square root of 84. And that's 9.17. So I'll just write that down. Okay, I got that. And it looks like the closest approximate answer is going to be A. Okay, next one. So I said blah, 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 blah. They're asking for closest to the length of the frame support. So this is my frame support. So they want the red line, right? They told us that from here to here is 16. So that lines up with there, all right? This is a guy I don't know. Here's my right angle. So that means this guy is C. Here's B. Here's A. Let me write out my formula. Let me go ahead and match up everybody. So my C's, my A's, as well as my B's. Let's write them in. 16 squared plus B squared, plus 4.2 squared equals C squared, because I don't know C squared. All right, let's go ahead and put that in the calculator. 16 squared plus 4.2 squared, enter. 273.64 is equivalent to C squared. Okay, so now I need to take the square root on both sides. So C is going to be equal to second x squared to get my square root, and then I'm going to hit second and then this negative sign because that'll put in this number for me. I'm going to hit enter. 16.54. Go back and look, and it looks like D is going to be the closest answer. All right, last one. Let me go ahead and clear up a little bit of space. Okay. So to get home from work, Felix can either take the bike path through the rectangular park or ride his bike along the two sides of the park. How much further? So that means we're going to have to subtract. Would Felix travel by riding along the two sides of the park than he would taking a path through the park? Okay, so it gave us these two sides. See my right angle. This guy is C. Here's A. Here's B. Okay, let's figure out what C is. Okay, so my A, my B, as well as my C. Okay, so 0.7 squared plus 2.4 squared equals C squared. Let's put that in the calculator. 0.7 squared plus 2.4 squared, and that's 6.25. So let's go back to that, 6.25 here. So I'm going to take square root of both sides. I'm going to do that again, second square root, second answer, flu function, hit enter, 2.5. Okay, so notice they gave us that as an answer choice, but that's not necessarily right. They want to know the difference. So if he wrote on the inside, here it'd be 2.5. But if he rode along the outside, this purple path, we'd have to add those together. So 2.4 plus 0.7, 3.1. Okay, so now I need to find the difference, right? So I'll write that out. Difference equals 3.1 minus 2.5, which is 0.6. And that matches answer choice G. Good job. Go ahead and take your assessment checkpoint for me today, and have a good rest of your day.